Lesson 121 is about forming solids and symmetry. Now our first question says, what is the volume of the geometric solid formed by folding the shape along the dashed lines? Dimensions are in inches. So if we fold this shape along the dashed lines, and everything that we fold comes upward, can you see what shape we have? Well, if these four pieces were to come up, that would start to give us a box. And then if this piece folded over forward, well, we've got our box completed. Our technical name for our shape wouldn't be a box, it would be a rectangular prism. We'd have a face, then it would be going backwards, kind of like a shoebox. And our rectangular prism would look like this. Now we can go ahead and erase to make sure those lines look nice and neat. Now the second part is to find the volume. And to find the volume, we know that's the area of the base times the height. So volume equals area of base times the height. And we can look at this shape as we have it and find the area of the base. The base must be the bottom, so it's going to be 5, and this piece is 4. So the area of the base is going to be 20, and in this problem it's going to be 20 square inches. So volume V is going to equal 20 square inches times our height. Well, our height is how high it is, and this piece right here must be how high it is. It must be 3 inches high. So 20 times 3, the volume is going to be equal to 60. And this was area, so square inches. Square inches times inches gives us cubic inches. We've got to answer to the first problem. When we have these problems where we need to fold along dashed lines, you've got to use your imagination in order to figure out the shape you're going to get. Here we have another one. What is the volume of the geometric solid formed by folding the shape along the dashed line? Dimensions again are in inches. So if we fold these two pieces up, this up to cover these on the left hand side, and then this would swing down to the front, well, we must have a triangular prism. And the triangular prism would have a base that looks like this. It would be going backwards in space, and we'd have a shape that looked approximately, and that's not a very good last line. Let's fix that one. That would look kind of like this. So, if we have our triangular prism, the bases, remember there's always two bases. So the bases would actually be the front and the back here. So, this piece, or this piece, they would be our base. Our height, well, that would be the distance that we have across, like our length, and then we could figure it out. Well, volume is area of the base times the height. So here's one of our bases. Here's the other. So the area of that, well, base times height divided by 2. 3 times 4 divided by 2. 3 times 4, that's 12, and 12 divided by 2 is 6. So the area of our base is going to be 6 square inches. Now our height, we've got to figure out which one of these is our height. And we can see the height is the connecting point between these two bases. So the connecting point between the two bases, well, that must be right here. Or we could call that right here. It doesn't matter. Either way, they're 5. So 6 square inches times 5 inches, that'll give us our answer of 30 cubic inches. And we found the volume of this shape, which is a triangular prism. Now the next part of the lesson is about lines of symmetry, and we have to draw the lines of symmetry for the figures below. So to draw lines of symmetry, we always need to use straight lines, so use your ruler or a straight edge. And what lines of symmetry are, it's just a line that if we folded our shape across, or reflected our shape across, we'd get exactly the same thing on the other side. So here's one line of symmetry for our rectangle. And another line of symmetry for our rectangle would have to be across horizontally. We've got both our lines of symmetry. We can move on to the next question. Here we go. We've got it sort of looks like a beginning of a star. We've got a polygon here. We know it has 1, 2, 3, 4, 5, 6, 7, 8 sides, so it must be an octagon. One line of symmetry here would be like this. Now I'm going to take that line and I'm going to move it up a little bit. There we go. Because if we flipped or reflected the top, it would look exactly like the bottom. Let's find another one. We could do the same thing vertically. So we've got it going right through the middle. If we reflected the right half to the left half, it would be exactly the same thing. Now in this one, it looks like we may have more. Let's test. Let's say we had this. If we had this line, and we reflected the top left over the line, it would be exactly the same as the bottom right. So if we have that piece, we must have one more. We must have one that goes through the other two diagonals. And we need to move that just a little bit so that it's in the right position. I don't want to move the whole shape. Let's undo that move. We'll undo that last line actually. It'll be easier just to redraw it. So if you don't have it drawn perfectly the first time, that's okay. Use an eraser. And then you can get it correct the second time. So here we go. I'm going to make them both a little bit low so we can move the whole thing. And that looks pretty close to our last line of symmetry. So if we had to say how many lines of symmetry there are 1, 2, 3, and 4. Lesson practice will be on page 385. Make sure you've got your notes complete, and I'll see you during our next class.